Today we will learn constant head permeability test and falling head permeability test. Introduction. Permeability is a measure of the ease in which water can flow through a soil volume. It is one of the most important geotechnical parameters. However, it is probably the most difficult parameters to determine. In large part, it controls the strength and deformation behavior of soils. It directly affects the following: quantity of water that will flow toward an excavation, design of cutoffs beneath dams on permeable foundation, design of the clay layer for a landfill liner, application, estimation of quantity of underground seepage water under various hydraulic conditions, quantification of water during pumping for underground construction, stability analysis of slopes, earth dams and earth retaining structures, design of landfill liner. Scope of the test. The purpose of this test is to determine the permeability, hydraulic conductivity of a sandy soil by the constant head test method. There are two general types of permeability test methods that are routinely performed in the laboratory. 1. The constant head test method, and 2. The falling head test method. The constant head test method is used for permeable soils K is greater than 10 to 4 cm per second, and the falling head test is mainly used for less permeable soils K is less than 10 to 4 cm per second. Standard reference ASTM D2434 Standard test method for permeability of granular soils, constant head. Note: the falling head test method is not standardized. Significance. Permeability or hydraulic conductivity refers to the ease with which water can flow through a soil. This property is necessary for the calculation of seepage through earth dams or underseat pile walls, the calculation of the seepage rate from waste storage facilities, landfills, ponds, etc., and the permeability depends on the number of factors: the size of the soil grains, the properties of the pore fluid, the void ratio of the soil, the shape and arrangement of pores, the degree of saturation. Equipment: permeameter, tamper, balance, scoop, cylinders, watch or stopwatch, thermometer, filter paper. Figure 8.1 Permeability apparatus. Test procedure. A. Constant head test. 1. Measure the initial mass of the pan along with the dry soil M1. 2. Remove the cap and upper chamber of a permeameter by unscrewing the nulled cap nuts and lifting them off the tie rods. Measure the inside diameter of upper and lower chambers. Calculate the average inside diameter of the permeameter, capital T. 3. Place one porous stone on the inner support ring in the base of the chamber, then place a filter paper on top of the porous stone. 4. Mix the soil with a sufficient quantity of distilled water to prevent the segregation of particle sizes during placement into the permeameter. Enough water should be added so that the mixture may flow freely. 5. Using a scoop, pour the prepared soil into the lower chamber using a circular motion to fill it to a depth of 1.5 cm. A uniform layer should be formed. 6. Use the tamping device to compact the layer of soil. Use approximately 10 gram of the tamper per layer and provide uniform coverage of the soil surface. Repeat the compaction procedure until the soil is within 2 cm of the top of the lower chamber section. 7. Replace the upper chamber section, and don't forget the rubber gasket that goes between the chamber sections. Be careful not to disturb the soil that has already been compacted. Continue the placement operation until the level of the soil is about 2 cm. Below the rim of the upper chamber, level the top surface of the soil and place a filter paper and then the upper porous stone on it. 8. Place the compression spring on porous stone and replace the chamber cap and its sealing gasket. Secure the cap firmly with the cap nuts. 9. Measure the sample length at 4 locations around the circumference of the permeameter and compute the average length. Record it as the sample length. 10. Keep the pan with remaining soil in the drying oven. 11. Adjust the level of the funnel to allow the constant water level in it to remain a few inches above the top of the swell. 12. Connect the flexible tube from the tail of the funnel to the bottom outlet of the permeameter and keep the valves on top of the permeameter open. 13. Place tubing from the top outlet to sink to collect any water that may come out. 14. Open the bottom valve and allow the water to flow into the permeameter. 15. As soon as the water begins to flow out of the top control desiring valve, close the control valve, letting water flow out of the outlet from some time. 16. Close the bottom outlet valve and disconnect the tubing at the bottom. Connect the funnel tubing to the top side port. 17. Open the bottom outlet valve and raise the funnel to a convenient height to get a reasonable steady flow of water. 18. Allow adequate time for the flow pattern to stabilize. 19. Measure the time it takes to fill a volume of 750 to 1000 ml using the graduated cylinder and then measure the temperature of the water. Repeat this process 3 times and compute the average time and average volume and average temperature. Record the values as small t, capital Q and capital T respectively. 20. Measure the vertical distance between the funnel head level and the chamber outflow level and record the distance as small h. 21. Repeat steps 17 and 18 with different vertical distances. 22. Remove the pan from the drying oven and measure the final mass of the pan along with the dry swell M2. A. Falling head test. Calculation. 1. Calculate the permeability using the following equation. Kt is equal to QL by ATH, where capital T is equal to coefficient of permeability at temperature, capital T centimeter per second, capital L is equal to length of specimen in centimeters, small t is equal to time for discharge in seconds, capital Q is equal to volume of discharge in centimeter cube. Assume 1 ml is equal to 1 centimeter cube. Capital A is equal to cross-sectional area of permeameter is equal to pi d square by 4, where capital D is equal to inside diameter of the permeameter and small h is equal to hydraulic head difference across length capital L in centimeter of water, or it is equal to the vertical distance between the constant funnel head level and the chamber overflow level. 2. The viscosity of the water changes with temperature. As temperature increases, viscosity decreases and the permeability increases. The coefficient of permeability is standardized at 20 degrees C and the permeability at any temperature capital T is related to K20 by the following, where neta T and neta 20 are the viscosities at the temperature capital T of the test at 20 degrees C respectively. From table below, obtain the viscosities and compute K20. 3. Compute the dry density rho d of swell. Rho d is equal to m by v is equal to m1 minus m2 divided by LA.